Okay, we're down to the last two problems in the practice test. The first one is manipulating an image. We're going to have to use the Python image library. And all we have to do is just darken the picture by dividing the red, the green, and the blue component values in half. That'll get them closer to black, which should darken the entire picture. So let's flip back over to Wing. And so what we need here is we need to use the Python image library, and we need to use the part of that called image. And then we're going to open a file, and this is the path information to the file, and this is the name of the file to the right of the cursor here. And then we're going to show it just to see what it looks like before. And then we're going to, I just did these two lines here for readability. Image size sub 0 refers to the number of pixels horizontally, so that's the width. And image size sub 1 is the number of pixels vertically, so that's the height. And then this is our standard loop here. We're going to go across the picture 1 pixel at a time. When we are moving across, we're going to do an entire column of Y values underneath us. Then we'll go to the next pixel going across. We'll do all the values underneath it vertically, and we're going to read the pixel. Okay, so that part's just what we do all the time. And actually, we can fix this with just one command. We can do image.putPixel, and it needs to know the X and the Y, and then it needs to know the red, which is divided by 2, doing integer division, green divided by 2. If you do floating point division here, it's not going to like it, so it's expecting integers for this. Okay, and that's all we need to do. And then we get done, it'd be nice to see if the picture really got darker or not. So we're going to show our newly edited picture here. So let's go ahead and run it. And we should see a picture of the Statue of Liberty with a lot of blue in the background and some brown down here. And there we go. You can tell that the picture is quite a bit darker. So that's all there is. You just have to, this algorithm is used over and over for manipulating an image. And then you just have to decide in here, what are you going to do when you get to that pixel. Okay, now let's go back over to Word and look at the remaining question. Okay, we want to write a function here. The function is going to be called square. It's going to accept 3 arguments. The turtle, which I've been calling t, the length of one side of the square, and the number of squares to draw. We will assume that the pen color, pen width, turtle location, turtle direction will all have been determined before calling the function. So we don't need to worry about any of that. The function should draw the specified number of squares spaced at equal intervals in a circle. So if we say we want 100, side length of 100, and we want 5 of them, and here's the first one, starting going to face this way all the time if we start by default. That's going to draw this one, that's going to rotate a fifth of the circle, it's going to draw this one, fifth of the circle, draw this one, and draw this one. Down here we want 16, so the very first one is going to be this one. It's kind of hard to see here because they kind of run into each other and overlap, but that's our first square. Then it's going to do this one with this corner right here, and then this corner, and so on. So we need to write a function. So let's go back over here, and you need to write the function before you actually call it. So you define a function, and it's called square, and we're going to pass in a turtle. We're going to pass in the length of the side, and we're going to pass in the number of we'll call that count. The number of squares we want to draw. Okay. Well, if we want to draw a square, it is for, we'll do I in range. Spell range right. 4. And what I want to do is I want to, this will work better here too if I import. Down here, and if we type t dot. Okay, so I want to do t dot forward, and the autocomplete is not coming up here because I'm inside the function, so that's the problem here. I'll go forward the length of the side, and then I want to t dot to the left, 90 because of being square. Okay, now that's the code for drawing a square. What I'm going to do is I want to do that count times. So for j in range count, what I want to do is I want to draw a square. I need to tab that over. And when I'm done drawing a square, so I'll fall out of that uniformly, I want to turn. So I'm going to T-dot left, and the amount I want to turn is 360 divided by count. Okay, so if I'm doing 10 of them, I'll turn 36 degrees. If I'm doing 20 of them, I'll turn 18 degrees, so and so on. So this should work. I forgot one thing here. What do you call that? Equals turtle dot string. So now we've got a window to draw on. And now down here, let's just do square, and we'll pass it in t. And whoops, and t, and then let's do 100, and we'll do 5, just like an example. And let's go ahead and run that now. And I didn't comment this part out, so we're going to have to go through this first. Okay, and I didn't change any colors or pen widths or anything like that, so, and I also didn't do that little business about exit on click, but it appears to be working. So if you want to hold it up on the screen, you do win.exit on click, and that should keep it on. Let's get rid of this part, we'll just comment it out. And again, and it should start drawing design right away, and it should keep it on the screen here until we put the notes. Okay, so that takes care of the practice test. Make sure you can do all of this stuff, step through all the pixels, do things with the turtle. You'll be able to use your notes, you'll be able to pass programs to do this and cutting and pasting. When you do a function, make sure that you only use variables that are in the function. Don't try grabbing variables from out here. Okay, I'm going to uncomment this stuff, and then I'll put the file out there where it can be downloaded.